Welcome, Form 3s, to our lesson number 2A, our lesson for Form 3s, and we are still doing addition and subtraction of matrices. Addition and subtraction of matrices. And we are trying to solve our first example for today. Let's call it example 1. That's example 1 for today, where we are given these matrices that a matrix P is given by 11, 8, 1, 7, and a matrix Q is given by 5, 15, 8, 3, and a matrix R is given by that. And we are supposed to find matrix P minus matrix Q. Matrix Roman 2, we are doing matrix Q minus matrix P, and let's make it a plus. Roman 3, we are doing matrix R plus matrix Q. Remember what we said in the previous lesson? We said that for us to add or subtract matrices, these matrices must be of the same order. Now students, let's look at the orders. This is our order. How many rows? 1, 2. By how many columns? 1, 2. So this is a 2 by 2 matrix. Also, as you can see, this is a 2 by 2. And what about this one? How many rows? 1, 2, 3 by 1, 2, 3. So this is a 3 by 3 matrix. Therefore, we said that addition and subtraction is possible if those matrices belong to the same order. Now, let's attempt Roman 1. Let's attempt Roman 1, where we are subtracting matrix P minus matrix Q. Matrix P is 11, 8, 1, 7. I subtract matrix Q of 5, 15, 8, 3. This is the operation that we are supposed to do. Now, remember what they are of the same order. All of them belong to order 2 by 2. Therefore, addition or even subtraction is possible. So, we remember what we said in the previous lesson is that you look at element 1, 1, you subtract element 1, 1, element 1, 2 to element 1, 2, and so on and so forth. So 11 minus 5 is 6. 8 minus 15 is negative 7. 1 minus 8 is negative 7. 7 minus 3 is 4. And therefore, that is our answer for matrix P minus matrix Q. Let's do Roman 2, where Roman 2 was saying we are doing Roman 2 was matrix P, matrix Q plus matrix P. And what is that? This is 11, 8, 1, 7. We are adding 5, 15, 8, 3. That's addition. We are supposed to do addition of those two matrices. This is matrix Q and this is matrix P. And what will be our answer? We just do the same way. 11 plus 5, it will give us 16. 8 plus 15 will give us 23. 1 plus 8, it will give us 9. 7 plus 3 will give us 10. Therefore, our answer is in form of that matrix. Let's look at the last example. The last example where we were doing matrix R plus matrix Q. Let's attempt doing a matrix R plus matrix Q. Matrix R was given by 3, 4, 8, 2, 1, 0, 6, 8, 12. We are adding to matrix Q, which was given by 5, 15, 8, 3. As you can see, students, the first matrix is a 3 by 3. This is a 3 by 3. We have 3 rows and 3 columns, and this is a 2 by 2. Therefore, as you can see, they are not of the same order. Therefore, we say that this operation is not possible. This operation is not possible because these matrices don't belong to the same order. Therefore, addition or even subtraction is never possible. Addition and subtraction is not possible when these matrices belong to different orders. Therefore, we cannot proceed because those matrices belong to they don't belong to the same order. Now up to there, let's proceed, and now let's look at example number 2. This is where we are trying to find unknowns. We are finding unknowns of given matrices. We are trying to find those unknown elements that make up certain matrices. And I have formulated an example here to help us determine various unknowns. We are told that this matrix is equal to this matrix. This matrix is equal to this matrix. Therefore, it means that if this matrix is equal to this matrix, what that means is that the elements must also be equal. Those elements that are occupying specific places or specific positions must also be equal. For example, this element coincides with this element, the whole of this one. This element 12 will coincide with this one. As you can see, 12 is equal to 12. This element here, element 1, 2, must also be equal to element 1, 2, if and only if these matrices are equal. If they are equal, therefore, their elements, the magnitude of the elements must be equal. Element 1, 1 must be equal to element 1, 1. Element 1, 2 must be equal to element 1, 2. Element 2, 1 equal to element 2, 1. And element 2, 2 equal to element 2, 2 of the other corresponding matrix if they are equal. Therefore, we can perform simple algebra to help us determine these unknowns. And in this case, we have the unknowns as x, y, and z. We are trying to determine the values of x, y, and z. And we have determined that for these matrices, because they are separated by an equal sign, therefore the elements must be equal. Therefore, it means that this element 1, 1, we shall equate it to element 1, 1 because they are separated by an equal sign. Therefore, we can say that x plus 4 is equal to 11. Element 1, 1 is equal to element 1, 1 of the corresponding matrix because what exists between them is an equal sign. Therefore, from basic algebra, we can take 4 to the other side, and when 4 jumps over the equal sign, it becomes negative. Therefore, we can say that x is equal to 11 minus 4, and therefore, I can say that x is equal to 7. I have been able to determine the value of x as 7. Let's move on. When you look at this one, how can we therefore determine the value of y? We can simply determine the value of y by equating this one to the corresponding element of the other matrix. Therefore, if this is element 1, 2, we equate it to element 1, 2 of the other matrix. So y plus 6 must be equal to 8. Therefore, y is equal to, let's take it to the other side, it becomes a minus, it's equal to 8 minus 6, which is equal to 2. Therefore, y is equal to 2. We have been able to determine the value of y from that matrix. Let's find, as you can see, there is no unknown here. 12 is just equal to 12. The unknown is here. 3 plus z is equal to 7. Therefore, we can say that 3 plus z must give us 7. These matrices are the same. Therefore, we can take 3 to the other side, and we can say that z will be equal to 7 minus 3. This 3 is a positive here. Remember from integers, we say that those numbers that do not have a sign behind them, they are taken to be positive. So when it jumps over the equal sign, it will become a negative. So we can therefore say that z will be the same as 4. Up to there, are we understanding each other? I want to hope that you have understood up to there. We started here. We started by equating element, because we are told that these matrices are equal, because this is an equal sign, that this element is this matrix is equal to this matrix. Therefore, if these matrices are equal, then the elements must also be equal. Then it means that x plus 4 is equal to 11. X plus 4 is equal to 11. So we take 4 to the other side, we remain x. We remain with x as 7. We see this element will coincide with this element, and if the matrices are equal, then these elements must also be very equal. So y plus 6 must be equal to 8. We take 6 to the other side, it becomes a negative, and y will remain as 2. The last unknown is z. You can see that this element 2, 2 will coincide with element 2, 2 of this other matrix. Therefore, 3 plus z will be equal to 7. Therefore, if we take 3 to the other side, it means that z is equal to 4. And that's how we determine unknowns of given matrices. Hope you have understood, students. Let's attempt another example, example number 3, where we had asked to determine the unknowns of this given matrix. This is a bit complex. As you can see, the underlying factor here is the same. Both of these matrices are a 2 by 2. These are 2 by 2 matrix, and these are 2 by 2 matrix. And they are separated by an equal sign. Therefore, it means that these two matrices are equal. And if these matrices are equal, then the elements that make up these matrices must also be equal. As you can see, element 1, 1 here is 2. This is also 2. This element must also be equal to this one. This element 2 is equal to 2 and 3 is equal to 3. So the only unknown here is x. Therefore, we start by forming this equation that x squared plus 4 must be equal to negative 4x. And now let's bring this to the other side. This x to the 4x to the other side, it will become a positive. So we shall remain with x squared plus 4x plus 4 is equal to 0. As you can see, students of Form 3, that this is a quadratic expression. This is a quadratic expression that can be simplified by the methods that we did previously of completing square method. Completing square, you can also use the quadratic formula factorization method and be able to determine the roots of x. But for me here, because we are learning, let me do it very quickly. but for students you are going to 3. The first coefficient, as you can see, A is 1, B is 4, and C is also 4. So A is 1, B is 4, and C is also 4. So my x1, so as you can see, this is a perfect square and it has only one root, and x should be -2. So when you solve it by those methods that we did previously, you should be able to get, this is a quadratic expression. Solve it by those methods that we did of solving quadratic expressions of this nature. And you can use completing square method, you can use factorization method, and you can even use the quadratic formula. The quadratic formula, if you can remember from 3s, the quadratic formula looks like this: x is equal to minus b plus or minus the root of b squared minus 4ac and everything over 2a. This is the quadratic formula, and as I've told you, the value of a is the coefficient of x here. A is the coefficient of x, b is the coefficient, or a is the coefficient of x squared, b is the coefficient of x, and c is the constant number here. So just substitute them into this formula. This is the quadratic formula, and you should be able to get your x as 2. So the unknown here, so we can say that x is equal to 2. Now, for your homework, copy this question. If you have understood how to find unknowns of a given matrix, copy this question and do it during your free time. Do it during your free time. You have element 1, 1 here as x squared plus 5. Element 1, 2 is 0. So you can see it's 0 here. This is a -1 and this is a -1, and this also y is equal to 4x. Therefore, can you try finding the values of that particular example? Try to find it, and next time we are going to solve it. And for my students of Margmary Hills Girls High School, you are going to attempt, for my students, this is now for my students of Margmary Hills High School, you are going now to attempt exercise 8.1. You are going to attempt number 6a up to number 6i. Number 6a up to number 6i. Remember, we are using KLB Book 3 New Edition. Thank you for watching. My name is Mr. Mose. Mr. Mose B.O. Thank you. Remember to stay home and stay safe. Together, we are going to fight and win this war against coronavirus. Stay home, stay safe. Goodbye for today.